Hey guys, welcome back. Today we're going to be looking at how we can solve exponential equations as you can see right here. Now, I will tell you right now, this is for students who are in the Algebra 1 level and know the powers of exponents well. This video does not use any logarithms. I'm planning to do that for a future video when I get to the Algebra 2 stuff. So this one we're just going to be using properties of exponents here. Okay? Alright, so let's get started. Alright, so when we solve an exponential equation, the first thing that we want to make sure is that the bases, or the numbers that are being raised to a certain power, have to be equal on both sides of the equation. For these first few examples, they will be the case. However, when you get to problems like these or these, you're going to have to rewrite the expression using your properties of exponents. Okay? Now, once you have your bases set equal on both sides, then you can take your exponents and set those equal to each other. Like here, we have x plus 1 equals 5. Alright? And then if we subtract 1 on both sides, we get x to be equal to 4. How do we know this is true though? Well, I'm going to show you a little bit of a check. And check. The only time I'm going to be doing a check. So we substitute 4 for x. And then 3 to the power of 5. And then our answer should be 3 to the power of 5 equals 3 to the power of 5. I'm not going to evaluate the exponents, but you can already tell that these are going to be equal. Therefore, the solution checks. And that's why this method works here. Okay? Now, why don't you try this one? We have, I should have put my phone on silent. Oops. Alright, there we go. Anyways, we have 6 equals 6 to the power of 2x minus 3. So, one thing, okay, you don't need to see that either. Alright, so one thing you might notice is that the bases are set equal to each other, but 1 doesn't have an exponent. Well, if 1 doesn't have an exponent, then it's going to be raised to the power of 1. So this right here is raised to the power of 1. Okay? Alright, so use what I just told you, and use it to solve this equation. Give it a try. Pause the video and work it out. Come back when you're finished. Okay, so we're going to try this out. Bases are set equal to each other, so now we take their exponents. Remember that just 6 by itself has an exponent of 1, so it's going to be 1 equals 2x minus 3, because we're setting the exponents equal to each other. Add 3 on both sides, we get 4 to be equal to 2x. And then x equals 2. Alright. One more. I'm going to give you another example, give you another chance here. So we have 10 to the power of 3x equals 10 to the power of 2x plus 3. Why don't you try now? Pause the video and then come back once you've finished working this out. Okay, so the bases are set equal to each other, so now we just need to look at the exponents. So now we take this and take the exponents and set them equal to each other. We have variables on both sides, guys. So we need to get them all on one side, remember? So what we got to do is subtract 2x on both sides. And then you get x to be equal to 3. Simple. Alright, I'm actually going to break this down because I know I don't want to put any breaks here. Alright, so here's your next equation. 5 to the power of x equals 125. Now, this is a little bit of a challenging one because this time the bases are not set equal to each other. So then how do we do it then? Well, well, I will tell you that 5 to the power of something equals 125. What do you think that is? If you said 5 to the power of 3, you are correct. Correct. So what we do is to keep this as itself and then rewrite this to make sure that the base is 5. And so we get 5 cubed. Because you take 5 times 5, you get 25, and you multiply that by 5, you get 125. Alright? And then set the exponents equal to each other, you get a pretty easy solution. Alright? Alright. I'm going to do this one as well, because this one might get a little bit trickier if you don't understand this well. So we got 4 to the power of x equal to 2 to the power of x minus 3. So, for this one, we need to rewrite the expression again. It looks like that we can make the bases 2. Okay? So now, I'm actually going to put this in parentheses, 2 squared to the power of x equals 2x to the power of x minus 3. Now we can use the power of a power property. Remember that when you have a power of a power, as shown here, you take those exponents and multiply them together. You do that, and you will get 2 to the power of 2x. And then 2 to the power of x minus 3. Alright? Now we set the exponents equal to each other. We get 2x equals x minus 3. We got variables on both sides. We're going to cancel them out so they're only on one side. I'm going to subtract x here. So it's x equals negative 3. Alright. Alright. That's how it works. Alright, why don't you try this one? This one is a little bit trickier than the others because for this one, you have to rewrite the base on both sides. Alright. Okay? So go on, try it out. Pause the video, work it out, come back once you're finished. Alright, so that one was a little bit of a hard one. So if you did not understand that, don't worry. I'm going to explain it all. Alright, so let's take a look at these bases. That's the first thing we want to examine. We have 9. Take note that that is a perfect square of 3, because 3 squared equals 9. And then, as for 27, it's a perfect cube, because 3 cubed equals 27. So for this one, we can actually use 3 as our base here. It's neither 9 nor 27, it's 3. 3. And so 3 squared equals 9, so we're going to put that in parentheses here. And then x plus 2. We're going to put this in parentheses as well. It's 3 cubed to the power of x. Remember the power of a power property. So we multiply the exponents together. So it's going to be 3 to the power of 2 times x plus 2, which is 2x plus 4. And then over here, we use the power of power property again. It's 3 times x, which is 3x. And then we set the exponents equal to each other. It's going to be 2x plus 4 equals 3x. We subtract 2x on both sides, and we can get x equals 4. Alright? That's how we rewrite expressions to solve equations. Now, what about this one? Uh-oh. What just happened? We got fractions now. Well, I'm gonna relieve your nerves right now and say that this is actually something that is raised to the power of -1. And guess what that answer is? I guess what base has the power of -1 to get 1/2? It's 2. So we gotta rewrite this as 2 to the power of -1. All raised to the power of x. And over here, we still don't have 2 as our base, but we know that 2 squared equals 4. So we can rewrite this as 2 squared, and that's it. Because, well, 4 is raised to the power of 1. Alright, now we use the power of a power property, and we will get 2 to the power of -x equals 2 to the power of 2. We set the exponents equal to each other and we get -x equals 2. Divide both sides by -1 and you get x to be equal to -2. Pretty interesting, right? Alright, this is going to be our last one for the day, guys. So we have 4 to the power of x plus 1 equal to 1/64. This time you do not have to rewrite both sides. You can just rewrite one, okay? So pause the video, work this out on your own, and come back once you're finished. Okay, so we have 4 as the base of 1x as our exponent on the left side. And then on the right side we have 1/64. Now, we can already tell that this is going to be a negative exponent because it's 1 over a number. Now, 4 to the power of what equals 64? If you answered 3, then you are correct. So we're going to rewrite this as 4 to the power of x plus 1 equal to, and you do not need parentheses here. It's going to be 4 to the power of -3 because it's going to turn this into this. All right. Now we set the exponents equal to each other, and then we solve. And if you got -4 as your answer, good job. Well, guys, that's how we solve some of the basic exponential equations. You're going to be solving a few more advanced ones in Algebra 2, but that's all I'm going to throw at you today. Anyways, that's it for exponential functions and equations today, the equations for this unit. So next time, we're going to do so what's left for Algebra 1? So what's left is that we're going to do a very small unit on sequences, which is going to be like 3 videos only. And then we're going to get to polynomials. We're going to be learning how to add, subtract, multiply them, factor them, solve equations with them. And then we're going to graph some quadratic functions in 3 different forms. And then we're on to quadratic equations to finish off. And then I'm going to start making the geometry videos. Okay? So thanks so much, guys. Have a great rest of your day. And I hope to see you next time. Bye.